Hey guys, it's Steve on the Guru Brew. Let's jump right in and work on the CNC controller some more. If you've been following my videos, you know that I've been working on the machine itself, cleaning the room and getting ready to use the machine and hook it up, of course. So things are getting close, but I still have quite a bit more to do on the controller, even though it looks almost done. So let's jump right in here and get going and see what we can get done today. Let's get started. Yeah, I wanted to say thanks for letting me know about these connectors. Several of you guys left me comments and told me to buy these connectors. I think they're called aviation connectors. And they're for my stepper motors to my CNC machine. Pretty nice. These are 8-pin. They had all different ones that you could buy. I got the 8-pin. And you can see it's got a male and female. There's the nut that you would put inside your cabinet, and then this goes on the wire part. It has a groove here, so it only goes on one way. Then of course it locks up. So yeah, these are pretty sweet connectors. It's funny, my soldering iron that I showed a while back's got this same type of connector, except it's only like a 6-pin. So yeah, thanks for the tip. I like them. So I'm thinking something like that for the front panel for, X, Y, Z. Right about there. That'll be the indicator light. And a fuse holder. That should be everything I need on the front. Just testing it out. Now this board calls for a 24-volt fan DC, and I don't have one. I had one, but I used it on the other machine. This is a 12-volt, and I'm gonna have to put a regulator on it and run it off the 24. I know that's kind of silly, loading up regulators like that, but I don't feel comfortable changing this out because something else might depend on that regulator being a 24-volt, and I don't know for sure. So I'm just going to run these wires to this 12-volt regulator and then to the fan for a 12-volt. So I just followed the instructions on the package for the 5-volt regulator and hooked it up between the 24-volt and the fan. And I have enough room here on the side. I think I can just bolt it right to the metal. Here's the schematic for the voltage regulator that I used. And just so you know, this is the front view. I had to actually look that up because they didn't say. You could confuse that for the back or the front. Here's one of the relays hooked up to a single plug, and I have another one of these that I'll probably put on as well for the other plug. Anyway, I'll insert a diagram here of how I wired this. Notice this resistor is very important. This is the output, and then this is the input. Let me show you where the input goes. On the input, I have pin 14 for one of them, and I'll probably use 16 or 17 for the other, which is here. And then 5 volts here down on the board, and I'll share that among the two. But I'll put a diagram in how I wired this. 2.2K, red, 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 red. It's pretty important that this value be correct, so I'm just double checking. Here's where the 2 pins are for the relays, number 14 and 16. I could also use 1 and 17, but I won't be using those. All done. Those are the 2 solid state relays that control the 2 plugs in the back. And if you want to know how I hook these up with a couple parts, like just a resistor basically, check the description. I'll put a link to the schematic. I'm stealing this plate off this old video card. It has a serial port and 2 circles, and that's exactly what I need. 2 circles and a parallel port slot. This is really a video card slot, but it'll work for parallel. That'll work. I'm using a ribbon cable to take the end stops and the homing pins out the back of this box through a 9-pin type connector. So I'm going to use this and connect those there. And I thought I would use these little things. Might make it a little easier. So you can see how I soldered the headers onto those ribbon cables. Now I can just shove it in as one unit. So I have to very carefully check and make sure that these wires are all on there well. That way these won't come untwisted, you know. That'll rip those wires right out of there if it did. I feel like I need something solid to brace these wires so they don't move. So I'm going to use this and bend it to hold these. I'm sure you guys have seen these little connectors, and they're pretty great. You can use them to splice into a circuit, and I'm hooking up the power indicator, which is 110 volt. So I'm splicing into this line, and rather than cut it and shrink wrap it and do all that nonsense, I just put one of these connectors on the wire I want to splice into, and then I connect into here with the wire I want to add. Take some line pliers and squeeze. Sink that metal right down in there, and then close it over. Really like these. You have to get the ones that are the right size for your gauge of wire, but other than that, they work great. Yep. I'm connecting the stepper motor plugs to the board now. Big day. This means we're almost complete. Now, isn't that pretty? Now I gotta worry about a heat sink to go on top of these chips. It can share the same one. So I found this piece of aluminum plate that I can probably use. First thing is I'll cut it off. Right about there. I had to reroute these cables because they were going over this heat sink and I wasn't able to fit the cover on. So I just went this way and then one around that way. So it worked out. So now what I'm doing is I'm documenting all the pinouts. Yep. Well, I've been looking at this for a while now and I think I'm done. I think all that needs to be done for the time being is done. I've made notes about all the pins and where the wires go, so I'll know how to wire my motors and switches. And the only thing I need to do now is power it up and see if there's any smoke. You know, that magic smoke that escapes. There's only one way to find out. Let's take it into the other room and power it up. Before I turn it on, I thought I'd bring it in here for a dusting and blow any, solder remnants or little wire fragments or something like that that could cause a problem. Look at this setup I have over here to show you the features. I stole this Lazy Susan from my wife. Pretty cool, huh? So here it is. Somebody tell me how long it took me to make this. I can't remember. It wasn't in real time, so it's hard to tell. I would say I probably have maybe 20 hours. Maybe 20 hours in this. So, yeah, I'm pretty happy with it. I have powered it up before now, but not with the heat sink and the fan and the indicator, all that stuff. I still haven't made a plug for the stepper motor. I should do that to try it out. But yeah, let's just check voltages first and see if it powers up and there's no problems. I've got everything wired, tied down, wire wrapped, or glued, or fastened, you know. I made sure that the cover will fit on here. I had to reroute all these. I blew out all the metal dust. And I've checked all the connections to make sure there was no short circuits with my multimeter, you know. Coming up to here, all these plugs come up to here. So anyway, let's look back at the features. This fuse here protects the actual board, and that's its only job. This is a heatsink for the drivers. There's 3 of them down here. Here's the outputs for the motors here. On this side, this is our parallel port interface. It comes to the back, and then you plug in a parallel port back here. This plug is like a serial cable, but it goes to these pins, and these are your input pins for your switches, your stop switches, your home switches. Over here is hookup for a 24 volt fan, and I didn't have a 24 volt fan, so I used a 12 volt fan and ran it through a secondary 12 volt regulator here, and it's heat sinked. You can see the big transformer and the capacitors under here. Bolted right here is the rectifier for the DC voltage. On this side, this fuse protects these 2 outlets as well as the internal circuitry for the transformer. I have 1 extra hole here, and I may put these on their own breaker at some point. That's why I left that open. These 2 holes are for a probe that will go from ground and pin 15. I just don't have the connectors for that yet, but I'll get those. The 2 relays for the outlets, outlet 1, outlet 2. You can plug motors into this if you want. These are solid state relays, so they're optically isolated. This is the main power to the board, and you can see now that fuse that I talked about earlier, it goes to here. These trim pots, there's 3 of them. Once I decide what motor I'm going to use where, I'll adjust these for my amperage for my current handling. We'll go over that in another video. This is just an indicator light that's tapped into our power back here when the mains are on. Yeah, let's see what else. Up here, there's 3 places for input pins. Or no, I'm sorry, output pins. 14, 16, and 17. I'm using 14 and 16 for the solid state relays. 17 is the only pin that I'm not bringing out of this case. All the other pins are coming out of here or on the motor output. And that's really all there is to say. Yeah. Let me get the power cord. Let's plug it in. Let's go for broke. As with any new project that I build, I'm very nervous the first time I plug it in. So let's just go for it. Well, here we go. doing the sniff tests, you know. Everything appears to be working. Of course, I don't have any steppers attached yet. I know that fan's a little loud, sorry about that. But I need that fan. I'm pretty happy how I put that heatsink right in line with that. That was a good idea. Indicator light's working. I'll check a few voltages here. So we're getting almost 40 volts to the board, and that's okay because I think the max is 42. Obviously the regulators are getting power. There's a reference point on the board of 5 volts. Let me check that. Getting 6 volts on that puppy. That seems awful high. Hmm. 6 volts. I wonder if it's because I attach these relays. Well, that's good. I mean, I can't confirm that the motor section's working, but the voltages are there. I don't feel anything or see anything getting hot. So the next step's going to be to attach it to the computer. Let's get the cover on this thing. Fits. So there it is. There's the black cover. That don't look too bad. I kind of wish I would have painted this now, but I don't feel like taking all that stuff off, so let's fire it up with the cover on there. Yeah, man, I like that. To be honest with you, I really don't like the black. I've been thinking of another idea. Let me show it to you. Looks pretty good though, I think. Yeah, man. I could get used to that. I've got to buy some wire for my steppers too. Gotta make sure I get that. Okay, so yeah. I got the cover back off. What do you guys think about making a cover in plexiglass? Now, I wanted to bend it, but I got talking to Steve about it, and he thinks I should just do it in panels. It's probably a better idea, using these for the supports for the side, you know, more of this metal. I know this would be some extra work, and this thing's going to be under the table. But I like the homemade look of it, and it shows that there's a lot of work in here when you get looking at it, and people that like electronics, I think, would get a kick out of it. But anyway, I could use some of this stuff, aluminum angle, and I could get 4 pieces like that, and then you know, cut 3 panels of plexiglass and screw it together, or a rivet, and then screw it onto the case so I can remove it if I need to, you know. Or I can, if you guys think I can bend this in one jigger, I don't know. I've never bent this before, and I'd hate to ruin this expensive piece of Lexan. But if I think I can do it, I'm willing to give it a try. Let me know what you guys think in the comments. I'm going to leave this video for here, and who knows, maybe I'll make a box in Wednesday's video, so make sure you tune in for that. And let me know what you think about the project. I know I haven't hooked any motors up to it or to the computer, but I need to get this video out, and I don't want to take any more time for that. So we'll have that in another episode. I'm just happy I didn't see any smoke. So thanks for watching. Leave me your comment. Don't forget this. We'll see you. Bye for now.